Okay, so today's a bit of a review topic from grade 9, and not covered in the textbook so well, so we're going to spend a class making sure we're good distributors. Today we're going to look at the distributive property and polynomials. And I've been throwing around the word polynomial in our homework and in class, so let's put a definition to polynomial. Polynomial is an algebraic expression made up of a number of terms. And the number of terms can be any number of terms. So the three we're going to concentrate on in this entire unit are monomials. So a monomial is an algebraic expression with one term. And some examples of monomials are 3x squared, 7x, 3, negative 15 over 7y, and things like that. So there's only one piece. A binomial, so mono 1, binomial 2. A binomial is an algebraic expression with two terms. And examples being 2x plus 1, x squared minus 9. So these are examples of binomials. They have two terms. And a trinomial, as we would expect, has three terms. And these are the ones we're going to be looking at the most. So an example of a trinomial is x squared plus 3x plus 2, things like that. So hopefully what we've recognized is the number of terms in a polynomial is an addition-subtraction word. And by that I mean, in order to determine how many terms a polynomial has, really what that means is you look at how many pluses and minuses there are. And there always seems to be one more term. So for example, in our binomial 2x plus 1, we have two terms. And the reason we know there's two terms is there's one addition. And addition and subtraction separate the terms. So 2x is a single thing. It's superglued, if you want to think about it, by multiplication. So here's our one addition symbol, gives us two terms. And if we look at our other example, such as x squared plus 3x plus 2, in this case, we have two additions. Remember, it doesn't matter if it's addition or subtraction, addition and subtraction. What we see is there are two addition symbols, and that breaks this up into three pieces, and it has three terms. Okay, so those are what polynomials are, and that's the language we're using, and I guess they're just big, messy things. So last day we looked at addition and subtraction of polynomials using this notion of like terms. Algebraically, it's the same base raised to the same exponent. Pictorially, with algebra tiles, it's the same shape and size. Well, today we're going to look at multiplying and multiplying polynomials by monomial, pictorially and algebraically. And this process is usually called the distributive property. So again, you learned this in grade 8 and grade 9. There's nothing new, but what I want to do is I want to use this time to notice things, because when we unmultiply, if we remember how we multiplied, unmultiplying is a lot easier. So here's the important things with the distributive property. It gets rid of brackets. That's what it does. It's a multiplication word. So as we said, like terms is an addition subtraction word. the distributive property is a multiplication word. And another word instead of multiplication, it's also called expanding. When using the distributive property, you must be careful of integer arithmetic and basically sign rules. Positive times a positive, positive times negative, and so on. You have to be careful with your simple exponent rules. X times x is x squared. X times 6 is 6x. And we have to be careful with like terms. We know what like terms are. So these last two are what we talked about last class. Okay, so here's what I really wanted to go over the distributive property for. Again, you've done it for 2 years. You have these things, these ideas like going fishing and things like that, all important ideas. But I want to look at a better way of multiplying. And the better way of multiplying is using an area model of multiplication. And the shapes we're going to use are, the shape I'm always going to draw is a rectangle. So this area model of multiplication, we're going to look at rectangles. And rectangles are really easy to figure out the area. They're L times W, one of the dimensions times the other. So let me work through an example from elementary school when you learned how to multiply and you didn't learn how to do it this way. For instance, if we had 8 times 36, you would have rewritten it to look like this, and you'd have done this little algorithm. You multiply 8 times 6 and you get 48, and you put the 8 down there, and then you put a little 4 above, and we get 8 times 3 is 24, and we add 2 and we get 28. So there's that algorithm. And hopefully you know that that 4 really represents 40, and this 3 really represents 30. But that gets lost in the algorithm. A better way to multiply is this idea of an area model. And if we want to multiply 8 times 36, what we can do is we can break the nastier part of the number into two nice pieces, 30 and 6. And then what we can do is we can just do each one of these multiplications. Again, L times W, 8 times 30, L times W, 8 times 6. And when we get that together, we end up with 288. So when we add together all of the inside, we get 288. And this is called the area model multiplication, and it's really nice. It makes sure you don't forget things. And if you learned this in elementary school, like some of you may have, when you get to high school, you have a better understanding of multiplying these things. So here is, we're going to multiply a monomial times a binomial. And again, in grade 8 and 9, you probably heard this term go fishing. I'll go through that in a sec. But here's the way I'd like to look at it. And again, you don't have to do it my way, but I think my way is going to be beneficial. Nothing has to be to scale. We're going to multiply x times 3x plus 4. And what we're going to do is we're going to figure out the area of each of these little squares, and then to get the final answer, we're going to combine the two. So here's where we have to be careful about integer arithmetic, sign rules, exponent rules, and like terms. So we have x times x squared. And again, the one thing I want to remind you, when you multiply a monomial times a monomial, like I just did there, what we want to remember are this simple statement. We want to put numbers with numbers and letters with letters. So I did this in my head, and I'm sure you guys can do it in your head. But when I figured out 3x squared, I multiplied 1 times 3, So in the example, we have 1x times 3x. Well, really what I did is I went 1 times 3 and x times x. And there's where we get our 3x squared. So again, when you're multiplying monomials, follow these simple rules. Numbers with numbers, letters with letters. And x times 4 is 4x. So therefore, our answer to this, given that we do not have like terms, is 3x squared plus 4x. So probably somewhere in your other classes, you've done the distributive property like this. And you've gone fishing or whatever your teacher said, and you get the exact same answer. But there's something really nice about an area model. When you use an area model for multiplication, for the distributive property, you never forget to multiply all of the terms inside by what's outside, because you always have to fill in a space. So let's look at another example where I don't know, I don't think the algebra is any harder. So what we're going to do is our binomial has 2 pieces. So we're going to break up one of our dimensions into its 2 pieces. And our other dimension of our rectangle is going to be this. So here's this idea of L times W. And we go through and we do numbers with numbers, letters with letters. We get 2 times 2 is 4, x squared. Our next one, we get numbers with numbers, letters with letters. 2 times negative 3 is negative 6, and x squared times x is x cubed. And to answer the question, finally, we combine any like terms, and in this one there are no like terms, so we just leave it. Again, if we were going to do this by going fishing or whatever your teacher said, we would do as above. And the only thing I want to say about this one is when you have something other than a single X or a number or whatever might be in front of the brackets, you want to make a note to highlight what you are multiplying into the brackets. So right here I've highlighted it's the entire 2x squared, not the x squared or not the 2 just by itself. And regardless, we get the same answer. So again, one of the common mistakes with distributive property is only multiplying the first term by the thing outside and forgetting about every other term. An area model, you can't forget that because you have a little space in your rectangle. So let's look at one last example. Over here is my dimension, and inside I have a trinomial, so I have to break the other dimension into 3 pieces. And then I go ahead and I do the exact same thing as before. So 3 times 3x squared, numbers times numbers, is 9x. 3 times 2x, numbers times numbers, is 6x. And finally 3 times 1, sign rules, is that. And our final answer is going to be what we see in the box because there are no like terms. Now I'm not going to do this last one using the fishing method, but it's exactly the same. So I just want to review. You do not have to do this area method of multiplication. Maybe you're really confident with distributing algebraically, and that's great. But you're more than welcome to do this. I think it's going to be valuable. It definitely is going to be valuable when we unmultiply. Things are going to be visible that you might be confused of if you just did the algebra.